Hello Science 30s. In this video we are going to be learning about titration analysis. Please go watch the video from Nate on how to do a step-by-step titration before you do this video. When we're doing a titration, the ultimate goal of any titration is to figure out the concentration of an unknown substance. The way that we do that is by utilizing acid-base indicators so that we know when an end point or when the titration is done. Once we have that point done, then we have volumes and we have concentrations, and usually we only have one unknown that we can then use formulas to figure out our our unknowns. So I said it ultimately comes down to a acid-base reaction. So take a couple minutes or a couple seconds right now and try and, on your own, pause the video and try and figure out which is the acid, which is the base, which is the conjugate acid, and which is the conjugate base in this formula right here, please. Okay, so now that you've done that, let's go through it. So in this particular formula, we have our acid, which is right here, reacting with our base to create two water molecules, which are split up here into the conjugate base and the conjugate acid. There are also two very important formulas that we are going to have to know for the titration analysis. Now, for people who have taken Chem 20, this is a much different animal, this titration analysis, as opposed to what you learned in Chem 20, because everything here is a 1-to-1 ratio. If you do not know what that means, do not worry about it. You can find these formulas on page 10 of your data booklet. So the very first formula that you're going to need to know is C is equal to N over V. C in this case is concentration, which is in moles per liter. N is your number of moles, which is in moles. And remember, moles just refers to the number of particles. And volume, or V, is volume, which is in liters. The second formula, which is written either as C1V1 equals C2V2, I think in your data booklet, it's CIVI equals CFVF. But ultimately, what I want you guys to think about when you're looking at this formula is that this side will be your acid, and this side will be your base. So as long as you make your C1V1 together to be your acid and your C2V2 together to be your base, you'll find that these questions come together a lot easier. So let's get right into an example. The example that we're going to look at is from your textbook, and here it is right here. So the table shows data from a titration of 4 10.0 milliliter samples of a solution containing hydronium ions and phenolphthalein using 0.130 mole per liter sodium hydroxide solution, which is the standard solution since we know that concentration. And our goal is to calculate the concentration of the hydronium ions in the acid solution. So what we need to do now is we need to figure out the unknown volumes. We need to actually use our calculators and figure out the volumes that have been added. And so sometimes what you'll find is that the tables will be vertical. This one's horizontal in a way. So you see that trial 1 is here, and here's your final titration reading, your final burette reading, and here's your initial burette reading. Sometimes these will be vertical. And so you just got to watch out for that within these trials. Watch for where your trials are. So trial 1 is here, trial 2 is right here, and just watch for that in your tables. And so the first thing we're going to do then is we're going to use our calculator, and we're going to go 13.44 minus 1.22, and we're going to get these four numbers all the way down here. This is going to be 11.98. And this will be 11.89. Now, you see we've done 4 trials. What we need to realize is that sometimes we go overboard. And if you've ever done a titration before, you know how easy it is to go overboard, or how hard it is to get that last little drop only. And so sometimes we add too much. and we really have to actually just throw those trials away. So what we see here is we see 3 different trials that are all pretty close to each other. And so we see that they're within about, these 2 right here, trials 2 and 4 are within 2 100ths of each other. And then this is only 7 100ths away from that. Whereas trial number 1 is considerably farther away. So what we're going to do is we're going to take our pen and we're just going to say, no, we're not going to count this one. And because that one is going to be an outlier. So now what we need to do is figure out the volume by adding up all of these volumes right here, the rest of the volumes. And so the volume of the standard solution, in this case, that was sodium hydroxide. So if we can think about that as our base, the volume of our base is going to equal 11.91 milliliters plus 11.98 milliliters plus 11.89 milliliters, and then divide that by 3. And we land up here with a volume of 11.93 milliliters as our average. So now that we've done that, we now need to figure out the rest of our variables. We have the volume of our base, the volume of our acid is going to equal, right here, 10 milliliters. 10 milliliters of so those would have been pipetted into the solution, so 10.0 milliliters. We have the concentration of the base is given to us. That is going to equal 0.130 moles per liter. And the thing that we need to figure out then, the only unknown we have, is the concentration of our acid. And so if we think now about this, we have C1V1 is equal to C2V2. And so we are solving for the concentration of the acid here, which in this case is going to be C1, because remember we said that this side was going to be our acid side and this side was going to be our base side. So let's take a look at how that works out here then. So we have our definition of variables up here, our volume of our base, which is V2, is equal to 11.93 milliliters. Volume of our acid, which is volume 1, is going to equal 10.0 milliliters. The concentration of our base, which is C2, is going to equal 0.130 moles per liter, and the concentration of our acid is our unknown. So we need to rearrange this formula. So C1V1 is equal to C2V2, and we need to divide by V1 on this side, divide by V1 on this side in order to get the C1 alone. So we land up with C1 is equaling C2V2 over V1, which is going to equal concentration 2, which is the concentration of our base, is 0.130 moles per liter. And we are going to be multiplying that by the volume of our base. Excuse me here, guys. By the volume of our base, which is 11.93 milliliters. And then we're dividing that all by the volume of our acid, which is 10.0 milliliters. Now we can leave, the reason why we could leave this in milliliters in this case is because you can see that they cancel out. And we're left with our units that we want, which is moles per liter. So get your calculators out, go ahead and do this, and you will find out that the concentration of your acid is 0.155 moles per liter. And of course, with that now, what we figured out is the concentration of the hydronium ions. So of course, a follow-up question on this could be, what is the pH then? And I'll leave that with you guys.